Welcome back to our Python lectures at SheGoesTech, and we will be looking at lists today. So we have seen strings, we have seen some primitive data types, and we will look at our first compound or slightly complex data type. It's probably the most fundamental data type you can have in Python, the most universal data type you can have for handling anything of medium to higher complexity data. So let's start with the big idea. Why do you need a list at all, right? So let's say you have a number of items. I should mention this is on our day 6 and the file is open lists.py, right? I have commented everything out, so if you want you can uncomment any lines you want. And so you have a number of variables, and it would be quite silly to do this, right? You have to store 100 values. I think this is not going to be fun. And again, if you are starting out as a programmer, everybody has done this at some point. If you don't read any, if you don't have any instruction, you don't have any knowledge, you will try to do something like this at some point, right? You have to store many values. Well, you just keep making variables, right? I mean, in some languages don't even have a list, this type of data structure, but Python does. So again, we can use to store all these values all in one place. So that's the reasoning why we need a list. I should mention that list is something called an array in other languages. Usually it's not related to a linked list. It's something different. It's basically an array. Basically it's a place to store basically pretty much all kinds of data, right? So the fundamental values, or I would say properties of a list, are that it's ordered. So there's some certain order. Doesn't mean it's sorted. We can sort it later on, but it's ordered in some way. So there will be some ordered way of accessing. It's again, anything goes in. Like I just said, it's a collection of arbitrary objects, and also it is possibly nested. That means it could be, you could have a list within a list, maybe something else. You can have a multiple levels of lists if you want, right? So multi-dimensional array perhaps, right? So it's mutable. It's a really important point. Unlike strings, you can change the values inside the list. Also, it's dynamic. So what does it mean? Dynamic means you can change the size of the list. So this is, like I said, it's a great universal data structure for Python, very convenient, but there is some trade-offs. Again, nothing in life is free, that it's not the most efficient as far as memory usage goes. Also speed-wise, if you need something for processing large amounts of data, you will want to look at some external Python libraries, and we will do this in a course, maybe in about 10 or 15 lectures. We'll look at some external libraries such as NumPy, right, which is, maybe you could say, closer to the metal, to the computer, so say more to actual represent. It's much better structure for handling large data. But okay, so with all that said, let's get started with our basic list, and usually we'll start with an empty list. So right, we can do this. So that's one way of doing it, right? Alternative would be to type empty list equals list. That's also another way of doing it. So square brackets. So notice the square brackets, right? So again, so when you see square brackets in Python, that usually, so to say, is kind of saying, okay, that's probably a list somewhere. So in Python, square brackets are used, well, are often used to denote a list, right? So let's print it. We'll print the values later, right? Let's check also how many values do we have. So how many values do you think we'll have here? Well, there should be 0, right? I hope you agree with me, right? So far. And let's take a look how it runs. And did it run? Yeah, we did run it. And there is a nice little 0. So yeah, so we made a list and it's empty. Okay, empty list. Again, we can add some values to it later. But oftentimes you want to add some values. And again, Python does not require you to have a very strict data type for the items inside the list. Unlike many languages which are statically typed, you have to define specific data type for your array, for example, right? You have to have all integers or all strings or all booleans. No, in Python you have no restrictions. Again, so often you'll find that many things work best if you have a certain data type inside your list, but overall you don't need a specific data type. So you have 5, 6, well, this is true, 3.6, and else, of course. By now you know that means beer in Latvian. So let's print it. So what will be the length? Let's think about this a little bit. So the length of this should be printed 1, 2, 3, 4, 5, 6. So 6 items, right? And type will be, most likely will be called list. If you notice that Visual Studio Code with a Python plugin, it tells you it gives you a hint. Okay, yeah, it already tells you the type, right? It kind of knows. And also you see them here, by the way, too, in the outline, right? You see them here as well. So let's run it. And yes, so it prints, right? It prints all the contents, right? And also it prints the type, and you can print the length, right? So prints type and length, right? Okay, thank you AI, thank you Copilot, and let's go. Now we come to the fun part, or the cool part. Well, if you learn your strings, which are basically a sequence of characters in some order, you can use the same syntax with lists, right? For accessing data. So yes, so just like our friend string, right? Lists also use same type of indexing. So this should be pretty easy once you get used to this indexing, right? So 0 based, we will print the first value, should be number 5, right? So this will be 0, 5, right? So, and it prints 5, right? So the major difference is that lists are mutable. Remember, we couldn't change values inside our strings, but lists let you do that. So I can I can even decide to change the type. This is an integer here, but I can change it to a string, Mr. 50, right? Let's do Mr. 50. I don't know why would I want to do that, but I could, right? So I have Mr. 50 now, right? So here, right? So now, as I mentioned, it uses same type of indexing as used in strings, and again, so Python is relatively consistent in this regard. So you can look at this again, refresh your memories how it works. So positive indexing starts at 0, 1, 2, 3, 4, 5. This is from Real Python, a good blog, a good site for learning Python, by the way. External site, good stuff there. So negative indexing, again, last item -1, -2, you know, so first item -6. Of course, this -6 because you have 6 items here, right? If your list is longer, this would be, let's say you had 8 items list, it would be -8, of course, here, right? So, right, so you have 2 ways of accessing data. So let's do the last element, right? Let's do the last element, my drink, right? And we'll see that this will be exactly the same. So drink, right? And also I can save it, right? I can save the results in a new variable, and I can print the last one directly. Of course, these should be exactly the same, and also I can print the positive index, right? Just like here, right? 5 and -1, in this case, it will give you exactly the same result. So let's see that in action. And aus again. So yes, this is the drink. All right. So now we come to the part to loops. So as we saw in our strings, right? Typical way of doing looping over some collection, like string or a list in this case, we use a for loop. We don't use range, right? I mean, we could, if you come from another language, using, yeah, we could do a range and we could do index, but no, typically we don't need a range of index, so we can use something like this for L representing element, right? My element, right? For L in my list, print L is type L. So you will see, of course, here we are storing what? Integer, string, boolean, float, and another string, right? So lots of different things, and so this syntax is for looping. Again, use colon and indentation, standard for loop. And let's see, yes, so we see that here, if I go a little bit up, right, Mr. 50, I don't think we can see the beginning. Yeah, Mr. 5 is type class integer, Mr. 50 is type class string. So this also explains why lists are relatively slow because you can store anything in them, right? You can store anything, so they need to make some allowance for, well, how do you store just arbitrary data, right? So you have some extra bookkeeping inside of these lists. The good news for you is that you don't have to worry about it. You just store stuff, right, and let the Python handle it. All right, so now you say, okay, but I want to know the index of my items. Well, again, you could use the range, but the Pythonic way is to use enumerate. So we do use enumerate. I think I showed you with the strings. So yeah, we can do this, right? So we can do for I element in enumerate. Again, this is built-in function. I mean, which returns enumerate. It returns basically on demand. So how does it work? It returns an index, or just you could say a counter if you want, on element from the list. So 2 items. Each time we run it, run a loop. So let's run it. So, and of course we can print and we can add more stuff, and then the loop is over here, right? So let's take a look. Right. So you see item 0. Right. Where is it? Yeah, item 0 is 5, and if you go here, right, it's 1. Item 1 is Mr. 50's type class string, while this says class string, right? So up to item 5, which is a 6th item. Again, index 5, but it's a 6th item, right? So, but okay, you say, okay, but I want some different numbering. Yes, enumerate has you covered, right? You can start with 1 if you want, or you can start with 100 or 1000. So in this example, we start with 1000. We start with 1000, right? And yes, we can do this. Yeah. So you see, item 1000 is 5. Again, it's just arbitrary numbering, and it gives you the results. Yeah, and okay, then you say, okay, but I want to store this arbitrary numbering. Well, yes, we can do that, and we can, in fact, I'll show you how you can create a 2-dimensional list using this item. Let's try this. So let's do this, and in fact, to make things more fun, right, we can do well, maybe a little bit more advanced, right? So I'll start with, say, 100. Start with 100. Let's say start is 100, right? Let's see what happens here. So I am giving a list. I'm enumerating a list, right, with numbers starting with 100, and I'll have it. I'm giving it another list. I'm making another list out of this collection of these pair of numbers. So what will I get? I will get a 2-dimensional list. This will be a 2-dimensional list, right? So list containing lists, right? So let's take a look. Sorry, and of course I can't type here. By now your example will have correct syntax right here, right? Not in list, does not take arguments, but I need, of course, list of this is not list of tuples, right? So let's take a look. Let's see a list. Yeah, so this actually gives you a list of tuples, actually, right? Tuples will be something we'll look in a couple lectures, but yeah, you can get a pair of these items, so you can pair them up, right? Pretty cool, actually, right? But this is something we will get back to later. But let's go back to something simpler, maybe. Let's go to our regular numbers. So how do you? So you saw this list, right? This is relatively slightly more advanced example, but very simple example is, what do you do if you want numbers, right? So remember, range is a factory, right? Range is not a list. It used to be a list in older Python before 2.7 and earlier versions. These days, range is, as sort of say, in Latvian you say half ready, sort of say preserved, or a factory which gives you numbers on demand. So you have to give it a list, create a list out of it. So this special word. So this is one of the reasons why you don't want to use a variable named list, right? Use my list or their list, or maybe use something called, very typical is use a plural. Yeah, use plural. So typical is to use plural for lists, right? Because numbers, right? This is going to be numbers. So philosophically speaking, right, this type of a list is well, again, platonically speaking, it's much better because it's same type. You can do more things with this type of list, right? So as I mentioned, you could do also using range, but I won't even mention it here. Yeah, you could do this using range, but this is not encouraged. Again, this code is sort of say, okay, this sort of screams you have done some programming before, but it's not very, I don't think it's as nice, right? You can use, say, range, right? You go through my list and you can print the numbers, right? It's again not very encouraged, right? So this is not very encouraged, right? So I will not talk about this approach, right? So okay, so let's go back to our let's go to some drinks. Let's go back to our drinks again. So I create a new list, right? So it's very typical to do this, right? So again, as we saw it for drinking drinks, right? List is plural, right? So this is very typical. So you have a list is again your collection, right? In this time it's a list. It's a plural. On the actual variable we'll do singular. Again, I think it's very readable, right? Again, this is I mean, then Python is just fun then, right? If you had to do some A and B, right, that would be kind of ugly, and you couldn't tell what's A, what's B. Here it's obvious. Oh, you're going through your drinks and you're doing something with a single drink, right? And of course you can actually drink it here, right? So as you can see, butter, juice, coffee, tea, milk, beer. Okay, very good. Right. So now that we've seen the basic idea of a list storing arbitrary values, but again, it works best if you store same type. Now let's do some slicing. If you remember our strings, right, we can do some slicing. So we can do things like this, right? My list. So this will be what? First three values, right? Yeah, right. So if I did, print drinks, first three, right? It will be first three drinks. So yeah, from the list, of course, right? Yeah, water, juice, coffee. So notice, these are still lists. So these are, they remain lists, just smaller lists. So we take a slice. So you take a slice of an existing list. Very, very convenient. So as remember, the zero is hidden or silent, right? The zero is silent. Okay, so we can take the last two, right? Let's do the last two. Let's do the last two. Yeah, right? And of course, if I did milk and beer, of course, it will also do that, right? Drinks, exactly the same. And -2, right? Last two, right? Milk and beer, right? You agree? Okay, great. So now, yeah, remembering our slicing, again, we have our slicing. Remember 0, 1, 2, 3, 4, 5, -6, 5, 4, 3, 2, 1 for 6 items, obviously. Right, so we can do this, right? My list, this will be from second to second. This is number 2, 3, 4. This is the fifth, so fifth item is not included, right? So again, maybe I'll do again print my drinks again, 1 to 4, right? Yeah, again, fifth is not included. Yeah, juice, coffee, tea, right? Mr. 50, well, this is true. Okay, right. So you can do something like this. So this will do everything starting from a second, but to the last, but not including the last one, because you're doing -1. If we skip this, if this was empty, right, then we would do it. We would do it. If this is empty, we will do it to the end, but we have -1, so the last item is not included, right? Okay, now show you also, let's remember our friend, the step, right? We can do that. We have an option to include a step. By default, step is silent value, or default value is 1, right? But we can have specified this 2, right? So 5, well, is 3.65, but let's maybe add some numbers, right? So let's do another number, right? So let's make a list of numbers. This will be 100, 110. So question is it going to be 200 here? No, because we have to add +1 or +2 here, right? Maybe 201, 202. So 200 is not going to be included, right? And step is going to be 10. So it's 110, 120, 130, and so on. Let's take a look. Right, and also we can print my numbers, which we already made, right? So my numbers, right, so we see them here, right? 100, 110, 120. So you can see how we can make them nicely from brain. So numbers, we can do my numbers or numbers. I'll show all examples. So this is all even numbers. When of course when I say even, it means index wise, right? I mean, let's see. No, yeah, this yeah, because we start with 0, right? So I'll show you both examples here, right? So this will be 0, right? So this will be my numbers was 100, right? So starting with 100, right? Yeah, starting with 100, 120, and yeah. Okay, so let's take a look. Yeah, exactly how I said it is. So you can see steps every second one. So odd numbers, when I say odd numbers, of course, odd index numbers, right? It doesn't mean there's no requirement that these numbers are actually odd, right? So we'll see that now indexing will be also, so index 1, index 2, index 3, index 5, and so on. So this will be what? 110, so 110, 130, and so on. Again, very smart. AI is very smart here. So we'll see step 2, right? To the end, right? So we can see, right? Again, in this case, these were actually really odd numbers, but they're technically oddly indexed, right? With odd index, actually. So odd numbers here, but really odd indexes, right? So actually, this happened to be odd, but of course, there's no requirement these numbers are odd. We just use the odd index, right? Here, same thing, right? Here, of course, they're all even numbers, but we use the indexing. So this is the first item. So what happened is, of course, this is actually a completely new list. These are all completely new lists. We just didn't save them. We could save them in a new variable, right, and start using them, right? So quite nice, right? So the slicing creates a completely new list in the memory, and you can assign to a new variable, and you can actually use it. Quite nice and useful. All right. So what else can we do with these lists, right? So as we remember, we could do this, right? And I will show you. So you can reverse a list, right? So else, and let's do one more. Print my numbers, right? My numbers, right? There we go. Look, notice how Visual Studio gives us an example. So yeah, it's a list, okay? And again, thank you, Colab. I'll do that, and it will be reversed, right? So, right. So you see how nicely it reverses these lists. Okay, there is, let's see how we're doing on time, because this is going to be a short lecture. Oh yeah, we're doing great. So let's keep going, and we can check reversed numbers. So what is this going to be? Well, it is not quite a reverse number itself. It's actually something called iterator. So kind of similar to what we used range is, again, it's not ready. It gives you values, but it does not give them, it gives them when you demand them. It's not actually ready list. So you'll see it's actually iterator, right? Special object. So why would you use this thing? Well, because if you, let's imagine you have billion items. Well, first of all, lists are not great for billion items. So you will want to use probably something else, NumPy array. But still, you are saying you want to go from the other side. So with this syntax, you create actually a new list, right, in memory, right? If you have, let's say you have 100 million items, you probably don't want to create another 100 million items in the memory just to store them as reverse numbers, the same data, right? So what you do is you use this trick, right? You would use this. So reversed is really useful if you want to go through something in reversed order, because it does not use more memory, right? You just basically say, it's saying go from numbers from the other side, but don't create any temporary values. Again, for really tiny data with 10 values, it really doesn't make any difference, right? But for larger data, this might be useful. For larger data, for iterating over large lists, largest in reverse order, so that is for large, truly large, right? So again, you could this will work, right? It prints them nicely in a reverse order as expected. So yeah, you could, but this would be really if you wanted actually a list of reverse numbers, but this is probably, you would want to use this probably, right? This is probably better. than list reversed, right? It will give you the same results, right? It will give you the same results. Okay, so what else can we do? Yeah, we can now have some fun with food, right? Remember, we had the problem with food of replacing things, and I think some people already in the class already know a little bit about lists, that we can mutate, right? So what we can do is this. Remember our string int float bool? I'll have a food kartupelis. Remember what kartupelis was? Remember kartupelis is a potato in Latvian. Oh, thank you, Copilot, right? So we have our food, right? So we can do stuff like this. So I'm going to create a list of characters, right? So it's typecasting list, right? So I say here's a string. So you can give anything which is a sequence. We had the range, right? So we can create a list of many things, right? So in this case, it's a character. You can't create a list of a single number, but if it's a list of, if it's a sequence of characters, which is a string, you know, by definition, you can create a list of characters, of individual characters. So let's take a look. So it should be individual characters here, right? So, right? So there you go, right? Food cars, right? So kartupelis, right? So we see that old and tired is P, right? Number 6, right? 0, 1, 2, 3, 4, 5, right? So we're going to replace the 6th element. This is going to be, well, what's it going to be? So old and tired P, new is M. Well, I didn't print everything. So now we have a list. We have made the replacements. Here's kartumelis, right? Melis is, so we change it from P to M. Okay, great. But now you say, okay, that's good. But I still have a list. What do I do? Well, you can go back to a string. You want to go back to a string. These are, well, technically these are 10 strings. These are just very tiny strings. But okay, but I want to go to a full big string of 10 characters. You think, okay, I'll do this. I'll do string. Well, this is not going to be quite what you want, right? If you do this, this is not going to give you the results. This is going to be basically what Python said very helpfully. Okay, you have a list like this. So this is actually a string, right? So it seems like it didn't do anything. Actually, it did, but it's not. It keeps the brackets, right? So this is a big string, but you have the commas, you have the quotes, single quotes, you have the brackets, right? Not quite what you want. So how in the world do you go back to a string like a real string? Well, here's a really nice, neat trick. It's called join. So you can join a list of strings, small strings together using this join method. So let's take a look what happens here. So this is kind of cool. So this is empty, so there's nothing. So we are joining each individual member of our list of characters with nothing. So nothing, 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 nothing. And so in effect we will have a nice big full string back again. So kartumelis now. So kartumelis, like I said. So join, it's a very useful technique used in also many other places, right? So other language also used, but they also for string manipulation. So what you can do, for example, you can use a food with space, right? Okay, why not? You can do this. Food again with space, sure. So this will have a space, right? So between each letter. And as you can see, yes, you do have space. Well, okay, you can go crazy if you want. You can add the smileys, you can add stars, whatever you want, right? This will also do it. So it will include food with a smile. So between each letter, you'll have a smileys with some stars, right? And you know, I don't know what. Somewhere maybe it might be useful, right? So you see cart. So you have all the middle, right? There's actually also doesn't print the smiley, it's not printed here very nicely on this screen. But yeah, but again, it's all so the actually what you're joining is more than the actual characters right here. But okay, yeah, so you can do this right pretty well. And again, you don't have to do this on just single letters. You can do this, right? You can do, for example, use a separator, right? And you can join it something like this. Let's say I have small list, Valdis likes beer, right? And I add three equality signs, and we will have Valdis likes beer like this. Okay, again, of course, now the thing is, you can do this. You say, okay, I want to join numbers. Well, unfortunately, it will not work like this. We'll need some little tricks. So this will not work. I can show you, but it will not work, right? We will need to convert the numbers to individual strings, right? So this won't work, right? But there are ways of around, right? So sequence, expected string. So this is only for strings. So this will not work, but we can solve it. We can solve this later. We can solve it. Then we can solve the above with list. Yeah, the conversion to be seen later on, right? Again, something to keep you get some little tension. So we're almost finished this time, but I will show you how you can make a list again. We made a list of individual letters, right? But what about, we can do something even better. We can actually do a split from anything. Like, for example, I could split kartupelis not by not with list, but I can use a split method. So this is the idea. I say split it with a p, right? And I'll be left with a list of kartu and elis, right? So kartu elis, but very typically you would do something like this. If you're processing text, right? You have a letter, you have a sentence, right? Of this, a quick brown fox jumped over sleeping dog, right? And you can use it. You can split it into words. Really cool stuff. So you split. You could do it like this, but even better would be to use it with nothing. So I will do it actually. Maybe later on I'll do split it. So I'll do something like this. So don't have to say anything, right? So this will be actually a list of words, right? So this will be, right? Right, a quick brown fox jumped over a sleeping dog. So by default, you have a string with some white space in between. You can split it by default into words, right? This will use any white space, right? So I will show you what's the differences. I will add some extra things here. I'll add maybe some space. Maybe I'll add some tabs here, right? Maybe tabs, right? Something like this, right? And it will ignore these basically, right? This is really nice. Notice here you have it, here you don't. So if you wanted to preserve this, right, I'll show you. We could also do this here, right? We could also print sentence split like this. Not quite, but strictly splitting by space only, by single space. So what will be different? Well, we'll keep all the extra characters, right? It won't ignore it won't. So this is really nice. I think the default method is usually what you want because it skips over all the extra stuff, right? Doesn't care if you have 3 white spaces or 6 white spaces, right? Here you are more strict. You're saying just split by 1 white space, and this will be, well, you see, you are left with 2 tabs. You're left with a single nothing here, right? Because you're splitting by white space, you're actually left with 3 single, basically strings of nothing. So generally, this is the regular basic split without anything is what you want, and you get nice list of words, right? So of course, then you can go back from words. How do you go back to a sentence? Again, we can go back to sentence, back to sentence, back to sentence, right? We can do like this. So as you can imagine, right? Yep. And print back to sentence, right? Back to sentence. Right, and let's take a look. So with this, I think I've given you a nice little introduction into what strings can do. So notice how nicely I changed it. And of course, but before that, let me change some words. Let's do words. Quick brown bear, right? Let's do bear, right? It's not fox, it's bear. Let's do that. Bear, right? Print words, right? Yeah, a quick brown bear, right? So we'll have a quick brown bear, right? So you can change it. It's very typical. You sort of deconstruct and then you construct. You use split your data in smaller chunks. Right? You do something with these chunks, right? With these individual members, these elements, and then you combine them together. In this case, this was just a long sentence, right? And you split it into individual words or tokens if you want, right? So, but this method, of course, is applicable to some other data types as well. Okay, but here it's string. So, I hope you got a nice introduction of what the lists can do. And in our second part, we will do some list methods to do, right? To see some to do. Let's add some to do. Explore a list. Yeah, more list methods. Thank you. How does Copilot read my mind? Yes, that's what I want to do. Explore more list methods. It's scary, right? Scary how AI knows my thoughts. All right. Hope you had fun, and I'll see you in the live session. Thank you.